Hi everyone, it's time to do section 6-9, which is on multiplying and dividing rational functions. Yesterday we added and subtracted. Today we're going to multiply and divide. This is one of my favorite things to do. I hope you enjoy it as much as I do. Now, before we start multiplying and dividing, it's really important that we understand what we can cancel and what we can't cancel. I mentioned this yesterday that you cannot cancel individual terms. That is a big no. Let's take a look. If we were to actually combine, this would equal 15/5 or 3. This would equal 10. They do not equal each other. You cannot cancel individual terms. You can't just see two things that look alike and cross them out. The only time you can cancel is if they are common factors, things being multiplied. So this 5 is being multiplied by the 10. There's no separate terms. Yes, you can cancel. Yes. Same thing here. It's being multiplied. It's okay that there's an expression here. It's still just two things being multiplied. There's no separate terms being added. So because of this, yes, you can cancel. So anyway, you can only cancel common factors. The main goal for simplifying when you are multiplying or dividing rational expressions is to factor everything. So we love factoring. It's our favorite F word. Let's just dive in and start factoring like crazy. So this top is a difference of squares, and the bottom factors into x plus 4, x minus 3. Now you look at these common factors, kaboom, kaboom, and they cancel, and you're left with x minus 4, x minus 3. Now some of you who are watching are probably thinking to yourself that this function, I'm going to choose a different color here, that this function right here does not equal this because the domain of this function is all reals where x does not equal -4 or 3, and the domain of this function is all reals where x does not equal 3. So technically these are not equal. They have different domains, but for today we are going to ignore domain restrictions. Now what we could do is write this answer and say, hey, it's this answer if we are given that x cannot equal -4. Again, that's just getting a little bit too complicated for this lesson. All we're learning today is factoring and canceling, and we don't have to worry about domain restrictions in this lesson. So don't let that bother you, just let that go. Okay, so let's start factoring everything. So our first numerator factors into 2x and x. We have a 3, we have a 1, we want a positive 5, so we want plus 6 minus 1. Our second expression here, our denominator, x, 3, 1, plus 3 minus 1. This guy, let me cross that off. This guy, x plus 1, x minus 1. Now this gets a little messy. Some people might want to just write a brand new set of fractions. I tend to just go messy, so I apologize to other teachers if you don't like this messy way of doing it. This is just old habit here. All right, so we want a plus 2 and a minus 1. All right, I'm going to grab a different color, and the fun thing is we are ready to just cancel. You can cancel anything that's on top with anything that's on the bottom. Why? Because we're multiplying. We're not adding, we're multiplying. So all of these are factors. So you can cancel. Let's see. 2x minus 1, goodbye. X plus 1, goodbye. X minus 1, goodbye. X plus 3, goodbye. What? Everything canceled. Does that mean that the answer is 0? No, the answer is 1. For example, if I have 4 over 4 and I can cancel the 4's top and bottom, it doesn't equal 0. 4 over 4 is 1. So if for some crazy reason everything cancels, then the answer is equal to 1. All right, let's factor again. This top numerator expression factors into x minus 2, x minus 1. There's really not much you can do here apart from thinking of the 25 as a 5 times 5. Everything else is factored. But we have something new. We're dividing. When you divide, you have to rewrite. So it's just like regular fractions. So I'm going to rewrite my first term. And we're going to turn this into a multiplication, and we're going to multiply by the reciprocal of our second term here. So 5x squared, x minus 1. Now we can start canceling. So what do I see in common? X minus 1's, goodbye. I can cancel a 5 with this 25, and there are 5 left. I can cancel one of my x's. I have an x, and I have an x squared. So now one of these x's goes away, so I just get rid of that squared part here. All right, let's write what's left. So I have an x minus 2, and I still have an x on top. On the bottom, the only thing that's left is 5. And this is absolutely fine. This would make me happy. Personally, when I just have a number on the bottom, I like to write it as a coefficient, and I think I like to put my x's in front, but that's okay. Only because when you get into higher level maths, it'll make it a little bit easier for you if you if you just have a number on the bottom to turn it into a coefficient. All right, moving on. Whoa, this looks scary. It's not. It's just another division problem. So, I think I'm going to factor everything first just for fun. So this guy, x plus 1, x minus 1. This guy, x plus 2, x plus 3. This one, x minus 2, x minus 1. And the last one doesn't really, it's just x plus 3. So here, if we rewrite our expression, so we have our top fraction, this guy right here, in factored form. And then what do we do with division? We multiply by the reciprocal of this guy. So we end up with an x plus 3 on top, and our factored x minus 2, x minus 1 on the bottom. All right, fun with canceling. X minus 1's, goodbye. X plus 3's, goodbye. Nothing else cancels, so what you're left with is an x plus 1 on top and an x plus 2, x minus 2 on the bottom. You might be tempted to multiply these together. Don't. This is simplified. Factored means simplified. If everything is factored, it's simplified. If you multiply this out, you're actually unsimplifying. So don't distribute it out. Just leave it how it is. Whoa, it looks scary. Let's have fun with this. We have to add first. We've got to handle our, think of this top as being like a grouping symbol. Believe it or not, this division creates two groups. It creates a top group and a bottom group. So we have to handle this group first before we get into our multiplication and division. So I'm going to factor. Let's rewrite this just so we can have a nice clean problem here. So we have x plus 2 times x plus 3 plus 2 over x plus 3 all over our beautiful denominator. We can go ahead and factor this if we want. All right, in order to handle the numerator, we need an LCD of the numerator. Now there's actually another trick for this that I think I'm going to include in the video on the next screen, but normally traditionally we would find an LCD of the numerator. Our LCD would be x plus 2 times x plus 3 because that would contain both numerators. So what we end up with is 1 over x plus 2 times x plus 3. So that guy's already over the LCD. This term has to be multiplied top and bottom by x plus 2. So what I end up with for my second term here is 2x plus 4 over my LCD. Then the denominator just comes along. And now if I combine like terms, I get 2x plus 5 over my LCD over my other denominator. And now I can turn this division problem into multiplication. So I have 2x plus 5 over my LCD x plus 2, x plus 3 times x plus 3 over x squared. All right, if we start canceling x plus 3's, goodbye, goodbye. And then we could also cancel one of these x's. An x with this x squared is gone. There is nothing else that cancels. Don't fall into the trap of like seeing this x and this x. This is not a whole factor. It's just part of one term. You cannot cancel it. So instead, our final answer would be 2x plus 5 on top over x times x plus 2 on the bottom. And that would be our final answer. And